The broadcast is now starting. All attendees are in listen-only mode.
All right, everyone. Would like to welcome everyone back to another KevCAM night class tonight. Tonight we're going to be missing Greg again. So for those that have watched the classes before, Greg's traveling, but I do see some new names in here. So I'll just go over some quick housekeeping. Everybody is on mute just to eliminate any background noise currently. If you guys do have a question, there is a question panel for you guys. So definitely I urge you to type your question in there and I'll answer it right away. Completely laid back. All the night classes are being recorded. So if you guys ever come across and you would like to see a previous night class or a tips and tricks or whole slew of videos right here. So if you guys go to YouTube and type in SolidCAM University or KevCAM, it will pull up and there is a video on how to do everything inside our software, plus all of our night class previous videos there. As well as something I haven't mentioned before, but right here, for those of you guys that have wanted a form for SolidCAM, it is fully launched. For those of you guys would like to join it, I will put it in the chat right now for everyone. As soon as I can find the chat, there it is. Okay, so I just put a hyperlink in there. If you guys want to check out the form, definitely come check it out. Or if you guys want, you guys can just do a search for SolidCAM forms and it will pull up for you as well. All right, done with the rambling, and let's get the ball rolling tonight with our Masters of Mill Turn here. So just to kind of recap of what we've done so far, and get our part rotated around here. Let's go ahead and play these last three operations. And we'll go ahead and do this in Solid Verify. And for those of you guys that are looking right now and you're seeing the basically like a slug right there, if you guys are ever slugging something out in Solid Verify and you want that slug to disappear after it's done so you don't have to worry about a collision, you guys can go to your settings, go to General, and come down and turn on the automatic remove split solids. And now, if I go back to HostCAD and back to Solid Verify, I may just have to replay that through, but now we'll get a good representation of where we're at. So we got everything done on the main spindle, the turning and the mill turn side of it. And 2 weeks ago, we worked on the sub spindle. So we did a transfer and did a sub spindle, as well as all the turning operations. Now, if I go to my stock target comparison here, and I do an execute, I can see that I need to mill my hex out for both up on top, well on the bottom, as well as in the center here. And if I zoom in here, there's a chamfer that's going to be going around all of this right here, as well as over here, as well as over here. So let's get the ball rolling with programming on that sub spindle. So when we started working on that sub spindle, we started using Mac 2 position 1. So now what we need to do is create a Mac 2 position 2. So what ends up happening is I need my Z-axis to be coming out for my live tooling. Okay. So what I'm going to do is open up my Chord Sys Manager. I'm going to delete these two positions here. Okay. Now, like I said before, we need that Z-axis to be pointing out. So here is our Mac 2. And now I'm going to start our milling process. And I'm actually going to do just an eye machining for this one. So I'm going to come to my Mac 2 position 1, click my coordinate system button. And now I need to add a Mac 2 position 2 for my sub spindle, but with my Z going out. So I can tell it go off of my coordinate system 2, and my Z is pointing out, and I'm just going to do a quick flip around, get everything back lined up again. I'll go ahead and accept that. Now I got my Mac 2 position 2, and for this one, basically all I'm going to do is chain my outside of my stock as well as my outside boundary that I need to machine going all the way around. And I'm going to mark that chain as open for my stock so it knows to come from the outside working its way in. We'll go ahead and accept that. We'll go to our next piece, grab our tool. And I have a tool in here that is a 3/8. And I want it to finish the wall as well as the floor. My levels, I want it, so I face turned all the way up to this surface right here. So that's going to be my new start surface. Oh, actually, no, I'm sorry. I got this wrong. I'm doing this back border here. So that's my start. And then my end, flip my part over, grab that, and we'll tell it go an additional 20 thou past. Okay. And we're using iMachining level 8. Save and calculate here. And let's see what we got. So you can see we came in here, and actually what I'm going to do is get this zoomed out just a little bit for you guys so you can kind of see, get a good representation here. So there's our sub spindle, and I'll single step this through. In our STL holder here, we're going to be going around, so that the tool path is actually going around the outside. Let's slow this down here. Now, as we're running this through right now, you guys may be saying, well, my mill turn machine doesn't have enough Y travel, which is, I think, the case on this machine here. So what we can do, instead of our boy, I can't think today, our tool rotating going around the part, what we're going to do is turn our sub spindle into a 4th axis, and the tool is going to stay put, and then the sub spindle is going to rotate from there. So I'll show you exactly what I mean here. So if you don't have the room to do this option, speed this up here, we can also do, if we go to our motion control, turn on our 4th axis, and simulate this now. If we go back to our solid verify here, kind of get it positioned how it is in the machine. Oops, I got to go play that slower here. And I need to play that through in machine sim. So we'll pull up our machine sim here. All right. Wait for our part to get loaded in there. Okay. So if I zoom in here, this will give you a better representation of what we're doing. Slow this down. So like I said, we're turning our, you can see our back spindle turning right there, and then just our tool going in and out. So you guys do have that option as well. So this will minimize going all the way around the outside of the part and just staying on the one side right there. So you guys do have those two options right there. Let me speed this up a little bit here. Finish off those contours. Do our finish pass. All right, now we're good to go. Okay. So now I'm going to use that exact same tool path and everything to do my hex right here. So what I can do is just do save and copy. And then my geometry, I'll grab my stock again, as well as our smaller hex here, going around. And our tool is already set, so we're good there. And we're going to start at 0 and machine down to this face. Technology, we look good. We're running level 8. Go ahead and save and calculate here. And I forgot to do something. So let's simulate it here and I'll show you what I forgot. So as you guys can see right now, what it's doing is it's doing a helical entry coming in there. And the reason why it's doing that is it's trying to stay within that stock that I defined as well as that hex I defined. The one thing I forgot to do in here is mark that chain 1 is open. So now if I mark that chain is open, save and calculate, and if we simulate here, doing our finish pass on our floor and our wall, and now you can see we are right up to size. So, and let's go ahead and just do our stock target comparison. So I can see that I am going too deep right here. So I can see I'm actually cutting into my workpiece. So let's take a look and see what did I do wrong. If I go to my, it's because I still have that 20 thou in there from when I did that previous level. So that's why it's always good to solid verify and do that stock target comparison. So now let's run back to our solid verify here, play this through. All right, now get our stock target comparison here. Perfect. So now, as long as I'm green, yellow, or orange, I am right up to size. Now, the thing, we still have our center we got to get out of there. So let's do that next. So I'm going to make a save and copy again. And then this time, I'm going to go to my geometry, and I'm just going to go based off of selected faces. So I'm going to grab that face right there. Let it do its updated stock here. That looks good. We're finishing floor and wall. Everything looks good there. My levels are automatically filled out for me, so we can just do a save and calculate. And I can see that I got all my material out of there. Just do a quick solid verify here. All right. Make sure we're up to size. Yep, we're good. So now we can start focusing on those chamfers. So what I'm going to do now is turn off all my toolpath, and we're going to do our chamfers with a profile operation. So we're on Mac 2, position 2, which is the same as what we wanted to be on. Now for my chamfer, we'll just go ahead and do this one first. Go and grab my tool. And that one's towards the bottom. Yep, 21. Got a 1/4 inch spot drill here. Levels. So my upper level is going to be 0. My lower level is going to be 10 thou. We'll go to our technology and we'll say chamfer. And we are going to be working on the very tip right here. So let's kind of see what this looks like. So let's go to solid verify. Now this is our live tooling again. Try to get a good view here for you guys. Come on. So right here, I can see I'm working right on the tip of my spot drill. If I wanted to work a little bit farther in, I definitely can do that as well by coming right here, and we can just do like 200 thou, save and calculate, simulate this real quick. Solid verify. Now that number that I specified there for that 200 thou does not determine how deep this chamfer is. It only determines on how deep we're using of that tool. So if I get another side shot here, so now I can see instead of working on the tip of my spot drill, I'm working more on the outer diameter of that spot drill. Okay. So let's go ahead and play this through here, and we'll make sure we're up to size. Yep, we're good. So now I like my parameters, so I'm gonna make a copy and go to my geometry, grab that guy. Same tool. Levels are going to be different because this is a deeper chamfer. So we got a 50 thou chamfer here. Technology, I'm probably going to have to back this one down just because it's such a large chamfer. So we'll go back to the 50 thou that was there before, and let's see how this looks. Okay. We're looking good all the way up to size, so we're happy with that. Now, the only thing left we have to chamfer is we can see this blue line going all the way around. So we'll go ahead and tackle that next, which is quite simple. So we'll make another copy. And I'm going to change up my geometry to go around the outside. And still using the same tool. Now my levels are going to change on me. So we're at 9 thou deep. Still got our chamfer. See how this looks. Got our chamfer going all the way around. Double check it real quick. We're golden. Okay. Now, the only other thing that we have left on this part here is doing our drilled holes. Okay. So now, what we can do in here is we need to, and we're going to be doing this on the sub spindle. So let's go ahead and turn off our toolpath here. And now we need to specify that Z-axis going in the upwards direction so it's lined up with that hole. And the reason why is because we need to know which way that drill bit is coming in. So what I'm going to do is we'll open up our drilling op, click our chord assist button, we'll say add, and we'll be Mac to position 3, referencing, even though it says chord assist 1, it's referencing this chord assist here. Now just click on this flat diameter here, or the flat plane. My Z-axis is perfectly in line with it now. So I'll go ahead and accept that. And now I can grab my drill geometry. So a couple different, 2 different ways of kind of going about this. We can do this as the, we're going to be drilling and then rotating the spindle, moving around, drilling again. And that's going to be around our 4th axis. But what I'm going to show you guys a little bit different way of kind of going about it here. Just, I don't know, thinking outside the box. So I need to grab my spot drill and our levels. So my upper level is going to be set to 0. Well, actually, my upper level is going to be set to here. My drill depth is going to be set to 0. And I want to spot drill it to that size, which is 125. So I'm going to do 135. Technology, just doing a standard drill operation. Save and calculate. Okay, so now we can see we got our one drill hole in there. Now we're going to transform that. So if I go, I'm going to do a transformation using fourth axis. Going to include the original, and since I have 5 holes, I'm going to be 72 degrees, and I want 4 more inserted in there. Hit OK. Save and calculate, and now we can see we're coming and drilling all the way around. Okay, so that's our spot drill, and if we want to simulate that, we can definitely can here. Slow it down just a little bit. Spot drill, spot drill, spot drill. So you can see we got a nice clean spot drill there. Now, like I said before, make a copy. And all we're going to do is switch our tools. So now I do have a end mill that is mounted in the right area. I think, yeah, this one right here. So our 1/8 inch end mill. Levels still are going to be the same, except for I'm not going to go based off of diameter now. I am going to do based off of drill point. So now my drill depth is going to be down to my drill point there. And it's going to actually, I'm sorry, let me rephrase that. Since I picked a end mill, which is a flat bottom end mill and not a drill bit, you'll see that it doesn't give me the options to go off a cutter tip or full diameter. So when you're picking your levels, I don't want to pick the point that I come down to here. I want to pick right where it comes down to where the flat is. So hopefully that makes sense, because we've got a flat end mill and we want the diameter to reach right there. Okay. Then we're going to do a Peck, and let's just do a 100th step down. Okay. Save and calculate. And now if we simulate this, so you can see that we're doing our drilling all the way around. Now, if I go to here, if I fix steps, do 1, we should be able to see it pecking. So you can kind of see it's pecking out. All right. Now, any questions on what I've showed tonight? I know I've kind of went through a lot, but this is basically what I wanted to show you guys tonight, is getting used to using your sub spindle with your live tooling. And that's basically what we did here. So let's kind of go back through and let's simulate and see what we've done in the machine simulation here. Give it a second to load up. All right. So we got our part, get you a good, decent view here. And now if we play it through, we're going to do that outside hex. And as I'm watching this play through right now, I noticed one thing wrong. I accidentally told it to do a floor finish on that first hex. So that's why it's doing one additional pass there for that floor. So I'll just have to take that off. Okay, now we're going to go to the center. And I also have a very slow helix feed, apparently. Okay, so we did have one question come through as it was playing through the simulation here. And the question was, what happens when your chamfer tool is not offset enough and the tip is going into the part? So once this gets done playing through, I'll show you how that works. I mean, obviously, if we have a 1/4 inch chamfer, oh, we got a crash here. What are we doing here? So that crash that was just shown there is actually a tool holder hitting our hex right here. So if we zoom out a little bit and rotate, you'll see I still have a lot of open spots over here. So what we're going to be covering, well, not next week because I got to go on site, but in a few weeks, is reorganizing our tools and getting all of our tools to fit in there accordingly. But okay, so right here you can kind of see everything's finished off. Got a good finished part here, other than we're crashing in our holder, but we'll get that lined up. Now, getting back to the chamfer. So if we have a 1/4 inch chamfer right here, and we only have a 1/4 inch tool, obviously we're going to have a little bit of a lip here as well as a little bit of a lip here. Now, the easiest thing to do would be go to a larger chamfer tool or a spot drill. But if you don't have that ability to do that, what you guys can do is do that with HSS. So with HSS, you would be able to do limit determined by number of cuts. And we actually have, I go to chamfer here, step down chamfer. So this is the exact video that I'm talking about. So right here, it walks you through step by step. And actually, I think we did, or Mark did this one as a profile op. Yeah, he did this as a profile op using the offset feature with the angle there. So this is how you can set it up very easily and get that larger chamfer that's there for you guys. So that can help you out, Yancey. All right, any other questions? All right, I don't see anything coming through. So hopefully you guys got something out of tonight. Like I said, we do have another night class coming up. Let's see, we need to do the webinars here. So our next class will be, it's going to be a little while from here, but August 17th, just because we have a couple on-site trainings to do and trade shows. So, but if you guys are in the Cleveland area at PMTS, definitely come check us out. We'll have a full booth there. A lot of our guys will be there as well. So, but with that being said, I'll let everyone run here. Any questions, concerns come up along the way, send those over to me via email. For those of you that don't have my email, I'm typing it in right now in the chat for you. And for those of you guys that are watching on YouTube, it will be in the description below for you guys. So send over ideas, anything that you guys want to see. These classes are dedicated for you guys, so let me know what you guys want to see, and we'll go from there. All right, everyone, have a good rest of your night, and we will talk to you guys in a couple weeks to wrap up our last night class for the advanced mill turn. All right, guys, have a great rest of your night. Bye-bye.